It was good too. Welcome back to another video. Today's video is going to be a little bit different. We're pretty much going to be making a skill, except I'm going to be trying my best to explain every step of the stages of me making the skill, if that makes sense. So if you're a newer coder, this might be very beneficial. And if you guys would like to see more like this, make sure you guys drop a like and sub. We're trying to hit 2,000, so it'd be much appreciated. Yeah, join my Discord server. Link in the description. We're going to be open sourcing some more stuff there. We're trying to get it more active. And shout out to the guy that made the VFX. His Discord will be on screen. And without further ado, let's get straight into it. All right, so to begin, as you guys already know, I normally just don't really explain the code I do as well as I can. So in this video, I'm going to be trying my best to pretty much explain, initially say my thought process behind what I'm making and why I store certain things in certain services, etc. So to begin, as you can see here, we have two different VFXs. It obviously is not made by me. I don't do VFX. I'm gonna have the guy's Discord on screen. And yeah, this one is the Boogie Woogie, so when you actually teleport, and then this one is like when you land. This is for like when you land on the floor or whatever. You can see there, pretty nice smoke. So what I'm gonna do first of all is I'm gonna make a folder inside of replicated storage, and I'm gonna call it assets. This is simply just to store all of this stuff, because I could leave it in the workspace, but obviously I don't want it to be in the game when it doesn't need to be. So I store it in replicated storage to pretty much make it inaccessible until needed, if that makes sense. Obviously the client can still access it, which is why it's called replicated storage. So yeah, it's being taken when we need it. So first things first, to make this skill, we're gonna have to do a couple of things. We're gonna need a way to detect a user's input. So what I always do is I make a local script inside the starter character scripts to detect when they are typing or whatever input they're doing. All right, as you can see, we have done that now. Basically, UIS is short for user input service, and user input service is used to be able to detect when the user is typing something or like clicking something, right? So what I'm doing is, if it takes in two parameters, I should probably explain that first. The first parameter is always going to be the input. The second parameter will be the game process event, which is a boolean. So game process event is basically like stuff like if you're chatting or if you're clicking like off the screen or something. I don't know how to explain it, but yeah, basically if game process event, you just want to return end. And the reason you do that is because you don't want to be able to detect, for example, if the character is typing in chat and they type like, I don't know, maybe a word that has Z inside of it, this skill would still try to use the skill. So if I actually show you that, right? So if I undid this and I did, for example, I just warned the output or clicked Z, if I were to start the game, and now whenever I press Z, as you can see, it works when I'm typing and I press Z as well in the type, like in the chat here, you can see here, it's still detecting that I click Z. So now the problem with that is that if I wanted to make it so you're using a skill, then obviously, it would still work even though you're typing, which you don't want, which a lot of older games actually did have that problem for some reason. Anyway, now next thing we're going to do is we're going to use a module script. Module scripts are basically ways to almost isolate code in a way, so your code is more maintainable and readable and reusable, obviously. Because all I'm really going to do now is start the skill, but there's many ways you could do this. One way you could do it is by just hard coding it here and then firing the remote event to the server, whatever. But I like to do it in a module script just so everything is more centralized, right? So if I want to go into replicated storage, I make a folder and I call it modules. Inside of that, I add another module script. And then I'll call it, for example, Boogie, and I call it client, because obviously this is for the client, right? And you can change the name of the actual table that's been returned. But essentially all a module is, it's like a table, and the table is being returned back to the whatever script required it. So what's cool about it is you're able to store functions inside of these tables, and these functions can be used in different scripts. So what I'm going to do is I'm going to create a function that starts the Boogie Woogie skill, and it's going to be called by this script whenever you press Z. This makes it so if I wanted to change something inside the Boogie Woogie skill, I could easily change it here without having to touch any of the code here, because this code is specifically for detecting inputs. So that way you don't have any dependencies on different things. So if you broke one thing, nothing else would break. That kind of makes sense. So let's make a function, call it Boogie, we'll call it function starts. All right, so as you can see, I did the start method, which is a function. So basically this table here holds this function, and the function is called by the :start method. So then I'm then getting the character and the player. Mind you, if you did this on a server script, it wouldn't work, because the way module scripts work is, if you notice, if I were to type local player, it's a game players local player, you can see it auto fills it for me. But if this is on a server script, but you're using a module script, it would still autofill for you. So don't fall for the trap thinking that a module script lets you access, like for example, local player on a server. That doesn't work, right? The only reason why it does work is because the module doesn't know if it's going to be required by the server or the client yet. So this module, I gave it the name client, so I know that I'm only requiring it on the client. So that's done. If I were to require this on the server, I would get an error because obviously you can't access local player on the server. So yeah. All right, so the next thing that we did was, as you can see, we grabbed the player's camera. So to get the camera, obviously you can only do that on the client, and I used game.workspace on current camera, then the origin and the direction that the camera is facing. Now, to kind of explain this, the origin is basically the current position of the camera, and the direction of the camera is basically whatever direction the camera is facing. I'm going to try to visualize this in a second, and I multiply it by 100. That way the range, I guess you could say, of detection is 100 studs. So for an example, if add an attachment to like an invisible part or something to show you what I mean. So if I do this, take the transparency to 1 and add an attachment inside of it, imagine this attachment as like a position, right, or a direction. So currently you can see it has no range, and if I were to make it face this way, you can see that yellow line. That means this point, the vector, is facing in that direction, but it doesn't know how long in that direction it needs to travel. So we do multiply by 100 to let it know that it should go look in this direction and travel 100 studs in said direction. You guys get the point, right? And the reason why we do that is because when raycasting, you need to determine the start position and how far the ray should go in whatever direction you want it to go until it hits something, or reaches the max range, which is what you can see us doing here by getting the origin and the direction. Next, you can see here we make raycast parameters. Basically, raycast parameters is a way to like only include certain things in the raycast or only exclude certain things in the raycast. Mind you, I should probably explain what a raycast is. Imagine a raycast as like an invisible line that just goes from one point to the end point, and then if it hits something, it returns information about what it hit, or if it didn't hit anything, it just doesn't return anything, right? And you're able to use that to detect things like the floor, how far away the floor is from your character, if you're, something is colliding with you. It's useful for a lot of things, and it's used in like hit detection and whatnot. All right, so we added quite a bit. So first thing we did was we added a remote event, and a remote event is basically just a way for people to communicate from client to the server. That way, we're basically telling the server that we're trying to use the skill, and then we can pass in information to the server so you can know what to do with that skill. So here you can see I just referenced a remote event, which I'm going to fire later on. So the next thing I do is I get the result of the raycast, and I call it result. And to use the raycast, you just do workspace raycast, and you pass in the origin and the direction and the parameters that you want to use, which is just these. My parameters currently are just telling the raycast to ignore my character. So if for whatever reason the raycast interrupts with my character or detects my character, it will just ignore it and continue firing. So that's just like, make sure I don't hit myself with the skill basically. So now that that's out of the way, we're checking if the result, if the raycast actually returns something, meaning that it found something. Then we're checking if it's an instance. So what an instance is, like a part or like a model, whatever. Like we're checking if the raycast detected the instance that's in the game. And if it did, then we're just playing the animation here and waiting for an animation event to reach. The animation event in this case is called clap. And when you're making your animation, you can easily add animation events. And the whole reason you do it is just to like, instead of having to do like task or delay and try to guess the time you want to teleport, you can really make it accurate. So whenever this animation reaches this certain point, this code will run. And yeah. All right, so I added in the animation now. So when I run the game, yeah, okay. So if I hit something like, for example, the floor, I need to make my game R6, hold on. R6 animation. All right, so if I hit something like the floor, it doesn't work because we forgot to tell it to actually start. So inside of this script here, basically here is where we detected the hit. And here is what we want to do when we detected, sorry, here's where we detect the input. So when they press Z, we want to start something. And here's where we actually run the logic. And as you can see, it's much cleaner to do it this way. So now all I can do is require the module and then use the method that we defined. Obviously in a real system, you might want to make like a module loader that loads all the modules and like functions to like get certain modules. But in this case, it's very simple. Just require it. So we'll call it Boogie. To require, and then you have to get the path to the Boogie, which is just replicated storage modules.boogie is to require game replicated storage modules.boogie client. And now we can run that function we created here called start. We can do boogie colon start. And mind you, we don't need to pass in like the player or whatever, because this obviously is running on the client. So imagine this code just being copied from this module and pasted here whenever you run this function, instead of it have actually been there, making this code nicer and making this isolated from anything else, basically. So now when I join the game and I press Z, Boogie Woogie is not a valid member. Did I spell something wrong? Remote event. Okay, the remote event is supposed to be called Boogie Woogie. My fault. Alright, so now it should work. So I press Z, you can see it plays the animation, right? Now to show that the actual timing for the clap is correct, I'm just gonna print to the console landed, whatever, I guess that should work. So I press Z now, you can see the second it does the clap, it says landed. That way we can know, okay, this is when we want to actually teleport the character. Alright, so the next thing we have done is, after it reaches the clap, we're checking a couple of things. One, we're checking if the person we're trying to teleport to is a player or like a character, or if it's just a regular part, because I want to be able to teleport to actual parts on the floor, kind of like in the anime when Toto throws out like a rock or something, he can teleport to the rock, right? But the logic has to be a little bit different for the rock. Otherwise, like, you know, there can be situations where you teleport to this rock and like your character like is kind of in the floor, right? And you don't want that. So I kind of separate the logic just to make it more like manageable in case a situation like that. So essentially what I did was I created a folder called NPCs and I created a folder called players. So I'm going to make a server script, so whenever your character is added to the game, your character's parent is automatically set to the players folder. That way it can easily detect players, because all it's doing is it's checking if the result of the raycast instance is a descendant of that folder, or if it's a descendant of the NPC folder, meaning that it's either an NPC or a player, which also just means it has a model which can be used to teleport to. And as you can see here, I fired a remote event to the server, letting it know that it's a player TP. Otherwise, I fired a remote event to the server, letting it know that it's a part TP. That way we'll be able to tell the server which is which, and you know, different logic can happen depending on what was sent. I forgot to mention, I also use attributes for the part. So for an example, remember how I was able to teleport to the workspace? Now if I press Z on the workspace, nothing happens. And the reason being is because I made it so it only detects parts that have the attribute can Boogie Woogie. So for an example, say you were making a Battlegrounds game, you would spawn a part and then you set the parts attribute can Boogie Woogie to true. That way this script can detect any parts that you know you want to be teleportable to, because you don't want the situation where you get teleported like to the base plate and stuff. And obviously since this is on the client, hackers and experts, you know, they could change this to make it so like the base plate can teleport. So on the server, you're going to want to double check to make sure that the part actually has that attribute on the server. Otherwise your game can literally be easily exploitable. Like someone can teleport the entire base plate across the map and kill every player in the game. Like you don't want that happening. Alright, the next thing we did was create a script, a server-side script inside a server script service, which just means that this script is running on Roblox's servers, not your computer, so ex-players don't have access to what happens here. So now you can see here when I join the game, the script literally just puts my character inside the model players. That way the Boogie Woogie client script can actually detect my character. So when other players are inside here, you'll be able to detect other players as well. Alright, so this may look a little bit confusing, but I'm going to be explaining all of it as I go. So to begin, we create a function called get floor position. All this function does is it uses another raycast like we shown before, except it shoots a ray using the start position as like, you know, the origin, and direction being a vector 3 going 100 studs down. Basically it's 100 studs into the floor. And the reason why we're doing this is to detect exactly where the floor is. So as you know, the way I plan on scripting this is normally you teleport, right? Say the part is on the floor here, and I want to teleport my exact humanoid root part to this part. I would end up like my character will end up like halfway through the floor, kind of like this, right? Roblox does kind of fix it for you, and it'll make you like automatically TP up, but like it looks choppy and I don't like the way it looks. So what I do instead is I detect how far away the floor is from said part. Then I basically set your character's position to be above the floor. It's just a little bit of maths, but I'm going to be explaining how that works. And then instead of here, all I'm doing is checking if the character is in the air by shooting a small ray downwards of 5 studs. And if the ray hits something, then we know they're in the air. That's just to detect if the parts, for example, is flying. So an example would be if the part is over here, the ray shoots down, doesn't detect anything, it knows that the part is in the air. meaning that the part is not touching the floor, so I can safely teleport my character to this position. Obviously, we're gonna have to teleport it relative like to this position, so like my character's feet are gonna be at the bottom, not the middle of my character, because if I did the middle of my character here like this, you can kind of see how this could cause problems, right? Like say I moved it down like here, kind of see how even though the part is not touching the floor, my character's legs will be teleported into the floor, which we just don't want. So that's what this function basically checks for. It checks if they're in the air. So we do know now they're in the air, then we can just set our character's feet to like, you know, the bottom of this position. All right, so I made a couple of changes to the is in air function. So what I did was I made it so it either returns false or nil. So that way I can do here, if it's in the air, then it does certain logic. Otherwise, it just does this logic. I'm going to be explaining exactly what I do in a minute. So first things first, I check if it's a player that's attempting to teleport. I should probably explain first. Yeah, this is the remote event, and whenever the remote event is connected, blah blah blah, these are the arguments that I passed there. And the first argument is the player, and I'm ignoring the player because I don't care which player sent it. And the type in this case is player TP, because if you remember here, we passed in our player TP if it's a player or NPC, etc. And the character, aka my character, the target slash the target character slash target part. So what I'm doing is, if it's a player, I then get my position and the enemy position, and I'm just swapping the locations of the characters. So it works very simple. If we're gonna go like this and I press Z, you can see I swap locations the second the clap happens, and it works pretty well. But now for the part, here's where it gets a little bit tricky. Mind you, this is not even necessary. Like I could do the exact same thing, except just put the part's position to my position, and it would work the same, because Roblox is really good. But I did a different way, and I'll explain why. First things first, I get the floor position of my character, and I get the floor position of the cart's character, because mind you, this method only runs, this code only runs if it's not in the air, meaning that the part is like on the ground, like this for an example. So let me just put this back here. So this means now this part is on the floor, right? So this part's here is going to run, and all this is doing now is it's getting the exact position of the floor underneath the part, right? So now that it has the position of the floor for the character position, aka my position, and the part's position that I'm trying to teleport to, what I'm doing is I'm setting my character's humanoid root part position to the floor position plus vector 3.new, and I'm setting the character's humanoid root part size y value. I'll explain this in a second, don't worry. So essentially, imagine it like this. You can see here the size y of my humanoid root part is basically the size up and down, like this, from here where my mouse is here to there of the humanoid root part. So what I'm doing is I'm setting the humanoid root part's position to the part's floor position, which, for example, as you can see, the humanoid root part is right in the dead center of my character, right? And then the middle of it will be in the center of my character. So if I were to set the position to the ground, my character would basically spawn here. And Roblox does do a good job and actually teleports your character up, which works, but it doesn't look smooth or flawless, which is what I'm going for. So what I did is, sorry, something just happened, but anyways, I'm back. So what I was talking about was, you can see here, the current position is going to be here if I teleport to the ground, right? So I'm adding my character's humanoid root part to y, which is just the size like up and down like this. So it goes from here to about here, right? Because the full size of the y is basically the full size of my character's torso, if that makes sense. So instead of going from here to like here, and now we want to determine the extra last little bit of that character, which is just basically me doing the exact same thing, except I'm dividing it by 2, which will then give me basically just this little part that's underneath the floor right here, making it so my character spawns exactly right above like the floor of the part there. That's just to prevent situations for, like, for example, say this part was like rotated weirdly and it was inside the floor. I don't want to, if I just set my position, you can see here that center point there, that's where my humanoid root part would go, and it would just bug out. My character might fall over and stuff like that. It's annoying. So that just helps prevent it. Then here I just spawn a part to kind of show you exactly where it's going to be. I'll make the parts color different. I'll show you. So I'll do parts red color. New, let's put like really red, for example, right? So now if I were to teleport, for example, to a player, you can see it works normally. Then when I teleport to like this part, you can see it spawns this part right there, dead center inside my character's torso, which is exactly where I want my humanoid root part to be placed over the floor. And it works even if I'm on here, for example, on the spawn location. You can see I teleport right here, right in the middle, right in the middle. And then if I would have done it like a different way, where I just set the position without doing this, for example, let's just say I deleted the additional 0.5, or sorry, the additional half. I don't know why I said 0.5. So let's just say I delete this part here. Now my character will basically spawn. Let me demonstrate it again. My character would basically spawn like this, and then Roblox will automatically push me up, but it will kind of feel choppy, and you see exactly what I mean in a second now. So if I were to now teleport to this part, don't know if you kind of see it, but my character kind of goes up and like down and then up. I'm going to try to slow it down to show. See, I kind of go down and then up, but when I teleport to a player, it's instant and it just looks smoother. So the whole reason I did this whole calculation was to make sure the center of my character is centered, like, you know, with the part. And that's pretty much it. Obviously the in air, I can't be doing it. It's basically the same thing though, except I'm detecting where my character's feet is, and I'm setting the bottom position of the part here to the bottom position of my character's feet. That way, like, yeah, it doesn't look weird and it just works as intended. So let me undo what I just changed now. Then we need to add the VFX, and then we're pretty much done. Okay, let's add the VFX. Alright, so the last thing we've done now, as you can see, is we use the exact same remote event, except this time we're firing it to all clients. If you were worried about optimization and stuff, you might want to fire it to all clients within like a certain range. For example, like maybe like 50 stars or something, you do it. Otherwise, it doesn't matter. You can just do it to all clients. Mind you, you should probably never do like effects on the server because it's just not good. It's just better to do it on the client. And yeah, you can see here I fire it to all clients and I'm saying a name. Basically, this name is going to be the, I guess you could say like an identifier, so that client knows exactly what I'm trying to do with this event. Then I'm passing in the character, because the character is where I'm going to display the effects. Now on the client, I basically receive the remote event here. Then I connect it to an event with the skill name and the argument. And if the skill name is the Boogie Woogie teleport, I have a function here to just set up the VFX where I set the parent to the workspace, anchor it, can collide, and I set the VFX's position to the position passed in. Then I loop through everything inside the VFX and emit it. Then I add it to the bridge, which basically just destroys it after a certain amount of time, which in this case is 2 seconds. Then here you can see me referencing the 2 different VFXs. Then I just call the setup on both of them. So now when I use the skill and I press Z on an NPC, for example, you can see, or parts, I can swap positions with parts, players, and NPCs, which looks pretty good. Obviously, something you might want to do as well is you might want to make it so there's like, I guess you could say leeway. So you can see how if I'm aiming like right here, it's not going to hit. You might want to make it so it hits even within like almost like an invisible hitbox around it. Don't actually use a physical hitbox, there's ways to do it with scripting, but you can make it so if you hit like, I guess you could say like, let's just say 5 studs around the player, then it still detects it as a hit. That way you don't have to be pinpoint accurate. I think games like ABA do it, I'm not sure, because like, you know, lock-on skills and stuff, you don't have to be looking directly at them, but it would still detect it. So yeah, you can see there, boom, looks pretty nice. Yeah, that's about it.